Here we are on page 3 doing the solutions for these linear inequalities. So we'll start off with number 1. 3t plus 5 is greater than 12. Subtract 5, we get 3t is greater than 7. Divide by 3, we get t is greater than 7/3. Now we have been given 3 instructions to graph, to write in set notation and interval notation. So the first thing we're going to do is write it in set notation. Put a little colon. Sometimes people put a straight line there. We'll use either one of those. And then these braces to let you know that it is the set of all t such that t meets these conditions. Really, this is the meat of the solution, and this other stuff is kind of dressing to make it look nice. So we now do a graph, and looks like this. Let's mark 0, and I'm going to mark 7/3, somewhere around there. And we have that t is greater than 7/3. Now, in beginning algebra classes, you'll often learn that an open circle will tell you how to mark the number that isn't the solution. We're going to step it up and use this open-ended parenthesis, and then we are bigger than 7/3, and go like that. These two symbols mean the same thing, but you'll see with this one we can write the answer like this as well. Open-ended 7/3 to infinity. And we don't ever hit infinity. So here we have the set, the graph, and the interval notation. Alright, let's do number 2. 4m plus 2 is less than or equal to a negative 18. Subtract 2 from both sides, and we get 4m is less than or equal to a negative 20. And then divide both sides by 4, and we get m is less than or equal to a negative 5. Again, put this up here, make it look pretty, and that is now set notation. The graph will go like that, and we'll mark where 0 is, we'll mark where negative 5 is, somewhere around there. And we are going to be less than or equal to negative 5, so that means what used to be a solid dot we're going to use as a bracket, and we're smaller then, so it looks like that. And to write it in interval notation, it's the interval from negative infinity all the way up to negative 5. This guy does not get hit. This guy does indeed get hit as part of the solution. So again, set, graph, and interval notation. Number 3. Jump that in, we get 3x plus 12 minus 6x greater than or equal to 5x minus 10. If we put these two together, we get negative 3x plus 12 is greater than or equal to 5x minus 10. Add the 3x over here, and that's an 8x. Add the 10 over to that one, and we get a 22. So divide by 8, and we have x smaller than or equal to 22/8, which reduces down to 11/4. Draw the graph here. Oh, we better do our set notation. So you could write this as 11/4 is greater than or equal to x, or x is less than or equal to 11/4. Now with our graph, here's 0, and about there's 11/4. And x is on the smaller side of 11/4, and it is equal to it. So this equal means we're going to do what used to be a solid dot, and then we head down. In interval notation, that looks like negative infinity all the way up to 11/4, closed on that end, open on that end. Number 4. Negative 7p plus 3 is less than 24. So subtract 3 and you get negative 7p is less than 21. Divide by a negative 7, and this is p is greater than negative 3. Recall that when we solve and we divide by a negative number, it switches the directions, because negatives switch directions. So P is greater than negative 3. Let's make this into set notation. There we go. And now the graph. So here's 0, here's negative 3. And negative 3 is not an answer, so we use a parenthesis around that one, and we're going to be bigger than. So we are going to look like that. Go up here like so. So that is the interval from 3 up to positive infinity forever. Open, open. Number 5. Jump that in, we get 3/5 n plus 12/5 minus 2 is greater than or equal to 3/2 n. I think I'd like to get rid of all the fractions there, so I'm going to times everything by 10, times by 10, times by 10, times by 10, times by 10, just so it'll look a little bit nicer. 10 times 3/5, that's going to be a 6n plus 24 minus 20 greater than or equal to 10 times 3/2 is 15n. Subtract the 6n over there, and we get a 9n is less than or equal to 4. Divide by 9, and we have n smaller than or equal to 4/9. Put a little n dot dot, little set notation there, and we have set notation for the answer. Interval notation looks like, here's the number line. Let's mark a 0 on there. Let's mark 4/9 somewhere like about right there. Positive, and we have that 4/9 is bigger than or equal to n, which means n is smaller than or equal to 4/9. So bracket, because we can have n equals 4/9, and then it comes down like this. So we have negative infinity up to 4/9. Notice that the infinities will always have this open symbol because we can never quite reach it. But when we do hit 4/9 as an answer, that's when we use the brackets. All right, number 6. 3m less than negative 21. Divide by 3, divide by 3. We get m is less than negative 7. Notice we do not switch the signs on that one because we do not divide by a negative number. So m is, let's make that into a set notation. Make it look all pretty. Good. Then we have the number line. And there's 0 and negative 7 somewhere down there. And now notice that m is smaller than negative 7. It's not equal to, so that's where we're going to use this parenthesis again. There we go. And color that direction. So we are at negative infinity all the way up to negative 7 is the interval, open, and this one is open, meaning we can't hit negative 7 as an answer.